So exercise 10.02 is about vectors that are either parallel or perpendicular. So if they're parallel vectors, then the angle between them could be 0 degrees, or it could be 180 degrees. So if they're like vectors, then they've got the same direction and the angle between them is 0 degrees. So the dot product is the product of their magnitude times cos 0. Now cos 0, of course, is equal to 1. So therefore, the dot product is just equal to the product of their magnitudes if they're parallel and have the same direction. If they're unlike vectors, where they're parallel but have opposite directions, then it's cos of 180 degrees. The angle between them is 180. Now, cos of 180, of course, is negative 1. So in that case, the dot product is equal to the negative of the product of their magnitudes. So those are some quite useful little rules. So basically, if the dot product is equal to plus or minus the product of their magnitudes, then they're parallel vectors. Now, if they're perpendicular, of course, then the angle between them could be 90 degrees. It could also be 270 degrees. Generally speaking, that angle, we do look at the non-reflex angle. So really it's 90 degrees that we should be looking at. But let's have a look at this for 90 and 270. So if it's 90 degrees, cos of 90 equals 0, of course. So the dot product would equal 0. Also, if it's 270 degrees, cos of 270 does equal 0 also. So either 90 degrees or 270, you're going to get that the dot product equals 0. So therefore, if the dot product equals 0, then they are perpendicular. Okay, let's look at this example. We have to show that these two vectors are perpendicular. So we basically just need to look and show that the dot product equals 0. It's as simple as that. So the dot product is 3, 2 times negative 4, 6. So 3 times minus 4 and 2 times 6. 3 times minus 4 is negative 12. 2 times 6 is positive 12. So we add those, we do get 0. So therefore they are perpendicular. In question 2, we're just asked if these two vectors are parallel, and if so, are they like or unlike? So is the direction the same or the opposite? So we find the dot product. So 6 times 7.2 plus 5 times 6, which equals 73.2. Now, do notice too that when I do a dot, I always put it up a little bit higher, whereas here this decimal point is down low. So that is 5 times 6 there, and 73.2. Now, for parallel, I also need to find the product of their magnitudes. So we've got the magnitude of the vector 6, 5, and we multiply that by the magnitude of the vector 7.26. So the magnitude of 6, 5 is the square root of 6 squared plus 5 squared, and 72.6 is 7.2 squared plus 6 squared. You can just throw that all in your calculator, and it does equal 73.2. So therefore they are parallel, yes, they are. They're equal. Neither of them are negative, so they are like vectors, not unlike vectors. If one was negative, then they would be unlike.